I am going to quickly go through the process I took to create this test version of the Gibson SG body. This is not going to be a well-produced video. If you're looking for fancy bumpers and background music and all that, go somewhere else. Hopefully this will have some good information. I will try not to ramble on too much, but I'm going to go through my process that I took here, talk about my lessons learned, and discuss what I'm going to make, what changes I'm going to make for the next time I do this. So let's get started. Okay, quick look at the 3D model. So this is modeled in Fusion 360. I'll go through the process of creating this model later on. The process actually for cutting this will be is to cut this neck cavity here, and we're going to leave all of the electronics and the bridge placement for after the neck is installed. This is a trick I learned on the Gibson website where it was one of those documentaries for Gibson, and they mount the guitar before, or they mount the neck before drilling any of these, at least the bridge holes, so that way they can get a perfect placement of that bridge piece. I believe they actually route out the cavities here. I did not on this test sample piece, in part because it's not a real thing, and also because I don't have the actual pickups that I want to put in there. Granted, this is one that's not going to be used, and I probably could have and should have routed that out, but here we are. We also have holes for all of the electronics here, as well as the cavity routed down below with a little recess for the plastic cover. This is going to get redesigned as well. One thing to note here is we have these 6 stubs, and these are going to be locations for these locator holes. And that's going to allow us to drill locator holes and put in 1/4-inch dowel rods into those, and we drill the same holes in the workbench or in the spoil board itself, and that allows us to flip over the board and align it perfectly for the backside process. Here in the manufacturer tab, we have all of the different routing profiles. So there's actually going to be 3 processes. The first one is to do a facing operation to take down about 2 millimeters of material. Then we put in the 1/4-inch bit and we route out a lot of the profile. We route out the neck cavity, and we do some initial routing away of material for these neck contours right there. So we leave, I think, a 1/2 millimeter or 1 millimeter of material, and clean that up with a ball later on. So here is that second one for the ball. We put a 1/2-inch ball router on there and go back and forth and back and forth and back and forth, and then we go back and forth again a lot of times, but this gives a nice smooth finish there. There is an issue with this lower edge, and I'll show that later. Same thing at the bottom. And that's all the top. Ideally we would probably have we'd route out the cavities for the pickups, but we're not doing that. And here you can see the locator holes. The first thing that we do is we bore those locator holes right there. The position of those does not matter, because as long as we bore the same holes in the table, it's going to fit. One little trick is it's nice if these are not symmetrical. So like you can see here, this hole here is out much further than this one. This is a completely asymmetric hole pattern, not by design, but simply because it doesn't matter. And if we don't have it symmetric, then there only is one position that when you flip it over and put the pegs in, that it's gonna route out, or that it's gonna fall into the holes right. So if you happen to have the orientation wrong, left or right, there's only one orientation that will match on the table. Same thing on the bottom side here. We do a similar sort of profile. So this one's actually routed upside down. So the first thing is to bore the holes. It actually bores it into the table, not into the wood face. We do another facing operation and the similar sorts of cuts. This adaptive process here to route this cavity here takes almost an hour to route out. It's a long process. And the final one here, this is we do our final profile at the end here, which was supposed to, and it's not going to show properly, right? They're supposed to add some tabs here, so that when you cut it out, yeah, there's the tab that it was supposed to add. This is not calculated properly. So it was supposed to leave some of those tabs. There was an issue with how I did one of the facing operations that caused it to drop down an additional 1.5 millimeters. I'll show that at the end too. Anyway, we're going to do that final cutout there. That's not what I want to do for the final product, and I'll show you again why. So there's our model. Let's look at the video for the actual process to route this thing out. So this first pass here is our surfacing pass. I put in a router bit that is, well, I'll show it to you here. So this router bit here is a surfacing bit that I bought from Amazon for just under $15. All it has on it are 3 blades that are designed to simply mill off that top surface. It's kind of you could call it a poor man's planer. You're going to end up with some of these lines in between each pass. There's various ways to try to get rid of that. Really, it's just going to get taken out in the sanding process, so it's not that big of a deal. So one thing you'll notice here is I put my hands and my arms and everything into the workspace while it's routing. I have lost a finger by doing stupid things with woodworking tools, so do not do what I'm doing here. But the reason why I do that is we're surfacing the entire top surface of this this board, and I really want to hold it down, so I have to move some of the hold downs as it's routing. So I kind of wait for that lawnmower pass to go past the first one, and then I drive in some drywall screws all the way through into the workbench, and I'm going to then move the pieces in the middle at the end. This is not the way to do it. I have the way to do it, or at least how I'm going to fix, and all of these lessons learned. Making this particular material, or making this test article, was so valuable in order to learn what not to do and how to do that so that sanding or finishing or other things is going to be much easier. So this is that first step. We're taking off, I believe, 2 millimeters of material. We start off with a 39 millimeter board. The final guitar is 35 millimeters, so we're taking off 2 millimeters on the top, 2 millimeters on the bottom, and the guitar shows up in the middle. So the next bit to put in is a 1/4 inch router bit. I bought this 1/4 inch bit at an auction. I actually bought 2 of them. And the reason why we're starting this profile in the middle, and you can see a very dark edge around some of that, is that the first router bit that I put in, the very first operation, dropped this profile down. No, it dropped one of the registration holes right down on top of a drywall screw. And apparently router bit versus drywall screw, the router bit does not fare very well. I thought it was fine, but ended up just dinging the heck out of those bits, and it dulled and burned the material. In fact, I'll show you this picture. You can see that while it was burning, it generated embers, like literal embers, that was consuming the channel of material that was in there. So not good. I could have kind of blown on this and got a flame, so not cool at all. So this profile here, we're just going to go around and around and around. Whether you do the cutout first or you do the neck profile, somewhat of a matter of taste, but I do have a preference, and we'll talk about that again at the kind of the lessons learned at the end. So the goal of here is just to route out, it actually will route out about a half an inch of material around the outside. And the reason why we have a little bit of extra material routed out is so that the ball bit, when it goes through there and is trying to make that nice and smooth, it makes a very, it has enough clearance to be able to clear the material without running into the workspace. The inner profile for the neck is interesting. It's going to do an adaptive clearing to hog out a lot of that material. And since that neck dimension is so critical, we do some tracing and profiling steps to make sure that we have a nice, perfect glass smooth finish around the outside. For the Gibson SG, there's a 2-degree slope on the neck. The neck is actually, the neck is tilted down 2 degrees from the face of the body of the guitar. So there's a parallel surfacing step that will take out that material there. Other than that, we hog out some of the material for the wings in preparation for smoothing that over with the ball bit. Okay, this is a 1/2 inch roundover bit, so it's just I guess a ball sort of bit. It's got a 1/2 inch diameter, and the goal of this is just to go around and around along the edges of some of those profiles. And if you shave it off close enough and do enough steps, you end up with a nice flat surface. It is surprisingly flat. I have heard that if you use a larger diameter bit, like a 3/4 inch or a 1 inch bit, simply the diameter, since it's a much shallower angle, might give you a smoother finish with fewer passes. We're just using this, doesn't really matter. And so yeah, it's just going to go back and forth. And once you think it's done, it goes again and again and again. This takes quite a bit of time. This is about a 20-minute, 30-minute process to route out all of the little bevels for the SG. One thing I do not do here is there should be on some of the flatter parts, which are very few, but the idea is to put like an 1/8 inch round over bit and round that over. And I don't do that, thinking, you know what, I'm going to take that out in the sanding process. I'm trying to decide, do I sand that off or do I actually get a handheld router and go over it again with the proper bit? I'm not sure. I think for this, well, you know what, we're just going to have to see. Either way, I'm not going to cut that out with the with this type of router. In theory, I could actually put a round over bit and just hit the edges, but I'm not sure. I'm going to have to experiment with that and see if that works out. But this is the round over process. And at the end of that, after 2 or 3 hours of your life have been wasted listening to that router drone on and on and on, you get this. The raw profile on the left is what it looks like just coming right off of the table. At least with that surfacing profile that I did, it's pretty rough. There's a reasonable ridge between each one of those lines. Way less than a millimeter, probably 1/10 of a millimeter, 2/10 of a millimeter or so. But it's there. But a minute or two with a random orbit sander, and it takes it down to a very, very nice, smooth finish. No real complaints except just the it'd be nice to be able to take it off the table and have that look just butter smooth. So one option with this is to pre-surface the material way before it hits this process here. It can be problematic because a typical surface set of blades is going to be like a 13-inch wide, and for some guitar bodies, that's going to be it's going to be rough to do. But it's a possibility, and want to consider doing that, to send it over to some mill workshop to pre-surface these to an absolute thickness. That way I only have to worry about rounding out the edges and the profile. So something seriously to consider. And other than that, it looks really nice. So time to flip it over and see what side 2 does. So side 2, pretty much like side 1, except for routing out a neck cavity, we are going to route out the electronics cavity. In the drawing that I had, it showed the cavity as being completely open, and when I'm looking at that, I'm like, man, there is just so much material removed, and there's only like 5 millimeters of material that's holding these switches on. Didn't really like that, but I'll show you this picture. This is what the inside of a quote real Gibson SG looks like. So there's a little bit more supporting material around the switches and the guitar jack, or the 1/4-inch jack. So I'm at least going to add some material like I do here. One thing that I'd really like to do is, instead of routing completely open cavity like this, is to route individual switch cavities and then route small pathways in between the different switch cavities, so that there's a lot more supporting material and a lot more wood around that whole place there. I like that. I think it'd be really clean. It'd be really nice to do, and you can still wire it up just fine. You might just have to do a little bit of a design work ahead of time to make sure that you've made room and length and space for all of that electronics and wiring. Other than that, we just go around and around. A few mistakes with respect to ordering on this profile. That center cavity took a long time to route, about an hour or so. So this whole process was pretty time consuming, but ended up with a good profile here. One thing to note, actually, on the first side, we routed down all the way halfway through the body of the guitar. So 17.5 millimeters down from the surface, what was routed out. When I did it on this side, I made sure to leave, it was either, I think, maybe 3 millimeters of material around the entire guitar, in order to have that lateral support, so that there was, as it's routing out and doing stuff, it's not sloppy or floppy in there. I could use tabs, and I actually, at the very end, decide I want to be able to notch out the rest of that material with tabs. There's another lesson learned that I want to do instead, in order to take out more of that material with a flush trim cutting bit, and that way I don't have to sand any extra edges, and it'll be a nice perfect fit from top to bottom. So side 2, the ball bit pass, it's exactly the same as side 1. The profile is actually exactly the same too, just mirror imaged on the top side. There's possibly a detail with respect to where the points come to with on these horns. It's really close, and might want to check to see if I want to make a change, or maybe we're just gonna file that away properly, or sand it away after it's done with sandpaper, just to get that final edge just right. We'll have to see where that process ends up. So for this final look at, this is a video, and I'm just going to scrub through this and talk about it as I see it. This is hot off the presses, so I haven't touched the back surface at all with the sander, and wanted to just point out some details that are good and bad. One, you see there's kind of a tab there right at the edge of that, right here along the edge. That was intended to be attached to the kind of the scrap material that gets that holds this in place. There was an issue with the depth where that wasn't retained. We'll deal with that later. That's not a big concern. But one thing you'll notice here is this edge here. Now, right there, you can see that the top and the bottom are off by a half a millimeter or so. There's an edge right along there, and it's hard to tell exactly what went wrong. If you look at it, there's a little bit of skew, a little bit of twist, where there's I think this edge is clean. Yeah, so that edge is really clean. Oh no, it's not. It goes on the other underside. So what this actually indicates is that there was kind of a twist in the registration by, like I said, maybe a half a millimeter. And given how the registration pins are cut because of that router bit issue that I had with a broken router bit, I'm not surprised. I think the next time we're going to be a lot better. However, I'm not planning on cutting it out finally this way. My plan, and let me see if I can illustrate this here, is we're going to go, when we're routing out this general profile here, we're going to leave at least a millimeter of material on both the top and the bottom so that it's extra wide. And then after we've cut this all the way out, completely out of the surrounding material, we'll probably still do it while it's in the frame. But we'll figure that out exactly how to make that happen. But we're going to run through there with a flush trim cutting bit, and I can show that to you somewhere. But basically, it's just a long bit with a knife blade on the edge, and we're going to go around the entire thing, taking off that extra millimeter that we intentionally left, so that both the top and the bottom are perfectly trimmed with each other. I can sand this down. It's not a big deal. And if I had one of those sanders where it goes up and down and you just set it on a table and go around the edges, that'd be great. Eventually we'll get one of those. But for now, I think it'd be better is to intentionally leave that wide and trim the entire edge from top to bottom. Other than that, from this point of view, we are pretty good. Okay, let's talk about some issues that we've had, or the lessons learned. The first one, and I'm just going to pull this up here, is going to be in that surfacing pass. So really every pass is going to have probably something here. So what I really want to do is I want to be able to screw this down once and never take this piece off of the surface and do all of the bit changes and not have to remove this at all. That way this stays at one level. It is grounded to there. There's no lifting, there's no difference in elevation. It's just right there. So my plan is I'm going to generate a surfacing pass here that is going to leave these screws proud. So if you remember, there's like 2 millimeters of material above this, or there was. You can see that edge right there. And so I'm going to screw that down, and the surfacing pass is going to come right up to this and then stop and then go around it. And if I do my job right, and there's easy ways to make this work, it won't hit that screw. And so the plan actually is to probably throw in like an 1/8 inch bit, and we're going to draw out and mark on the surface of this wood all of the registration holes, all of the extra things, kind of an outline for the person running the machine of what to do and what not to do, where to put the screws, and exactly where, so that when you surface this, it's going to be perfect. And that's going to That's really going to change things. That's going to make this right for both the top and the bottom surface. One thing to perhaps be concerned about is that if we leave the material proud here on all four corners, essentially you've made a surface in the middle. In theory, could sag a little bit. I don't think that's going to be a problem. You could put some material underneath that, like a wedge. Maybe I'll put like a little wedge under there, just make sure that it's exactly the height of the material that we took off, and that way we're sure that the body of the guitar is not going to kind of sag down. That is a possible concern, but we'll figure out how to deal with that. The what's the next one? I talked about routing out the outside. You know, I think we're good here. Let me look at my material because I have it right next to me. And really, like after we sanded this, it looked beautiful. No issues at all with kind of the quality that we got out of this, except for the ones that I've noted. I'll be really interested to put a to make a neck and be able to fit a neck into here. That's going to be an interesting process. So other than that, I believe we're done. So we'll send this off, render it, and get it up on YouTube for all of the masses to look at. Have a great day.